All right, we actually have a lot to talk about today, so I'm really just going to get started. Sound good? You can hear me at the back? You know what I'm going to say if you can't? That is very good. Okay, we're learning something. We have to go through higher order functions, which is a fairly unintuitive thing, so let's pay attention to it. Then the data persistence stuff actually I think is not too difficult, but you know, your mileage may vary, so let's see how we go. Sound good? All right, so higher order functions are functions that return functions. Is this a JavaScript or a TypeScript feature? Not really. It's a programming language concept, but it's not actually possible in all types of programming languages. Usually languages in which there are first-class functions can do this. I suppose in something like C you could do it with pointers and things, but it would be quite difficult. So the idea is, you know, functions are first-class citizens, therefore return types from functions can be functions themselves. And when that is the case, this is when we have a higher order function. So they've got different names. They're function generators or function factories, but they're used when a function produces a function which you can then use. So let's make a bit more sense. Here's an example of a create multiplier function. So if we have a look at this line, the name of the function is create multiplier. It does something. So it accepts a parameter, which is just a number in this case. And what it does is return, right, because we're in the curly braces, so we have the return keyword. It returns this. So what is this? This is, well, what is this syntax telling us? What type of function? Anonymous function, an inline function, exactly right. So we're declaring a function in the expression that is being passed to the return statement. Making sense? So the function that we're declaring itself accepts a parameter n. And if you look at that, yeah, that's fine. And it returns a number. So this function does not return a function, it returns a value, right? Because that's what this is telling us here. And this is an inline function which multiplies n by number. Okay. Number is, so n is passed into the inner function, factor is coming from the outer function. Yep? Okay. How do we use this? So we call the higher order function obviously first, and we're passing in this case 2 or 3. So what we're passing in here is mapped over to what? Which variable? What's the name of the variable? I was going to put out a police check for you if you didn't come to the lecture. You're always here. Ah, that's the excuse this week. All right, okay, yeah. So which variable name is the 2 and then the 3 being mapped over to? Factor, very good. Do we all see that? That's this value here. It then gets evaluated in this expression by calling factor here. The inner function, which 2 integers are passed and mapped over to n. If you get this, you understand. No. Sorry. 5 and 5. Very good. So let's think about what's happening here. On these two lines, okay, well, let me finish here first. So we assign the result of create multiplier passing in 2 to the factor to the variable double, and then the one with 3 to the variable triple. Yep, makes sense. So what is the data type of double and triple? Which accept an n parameter, which is a number. Exactly right. So what do we do with those two variables? We can call them. And when we call them, you can imagine in your mind that it's this that we're calling. So the 5 and the 5 go into n. So the result is 5 times 2 or 5 times 3. Okay, we're seeing that? So that is higher order functions. If you can get your head around that, you understand them. But they get much more complicated. Well, like they don't get more complicated, but the application of them becomes more complex. But I think a good question to ask here is, what's the point? Do we agree? Like this seems quite complex to me, personally. I'm being honest. It's not intuitive, at least to my brain, as a programmer. It's a lot of complexity here for not a lot of value. I mean, who agrees with that? Because I could just pass in, factor, and n to a function. Right? Why are we doing all this? Like, complexity is bad in code. So why are we doing this? So there are more use cases once we look into what this pattern can do. So I would call this a pattern, right? Design patterns and things. And it's useful to generate higher order function, or the factory function is called create greeter. It accepts a string this time, which is the greeting. And it returns a function which accepts a name, and it returns a templated expression of greeting name. Okay? So I call, oh no, call failed. Let's call back. Liam? That's a GRM for you. Did that accept? Nope. Maybe. It said call failed and quit, so I called you back. Should we quit? Did you hang up the call? No. Do you want to hang it up now, please? I think it's gone. Oh yeah, that's all right. So I'll call you back. No, we're not on a call. Do you have internet? Do you want to call me? Oh, hold on. We're on a call. We're on a call. Yeah? Yes? Okay, cool. All right, sorry about that. Okay, we use that higher order function twice, and we're passing in the template of the greeting. So one's hello, one's g'day. So when we call those two generated functions with two different names, Alice and Bob, we will see hello Alice, g'day Bob. Okay? Still though, I'm not quite getting here why this is super relevant or useful. Do we still agree with that? Okay, so we've actually used this pattern before. So have you seen express.json in app.use? So that's a function generator. So express.json returns a function which gets passed to app.use, which is the function used in the callback when the server is started. So why is this pattern useful? So let's think about starting a server. Okay, let's think about starting a HTTP JSON server. What changes when I pass express.json versus if I pass express.text? the data type of the responses sent back to the requests. Okay. If you think about the total sum of computation required to respond to an endpoint, what percentage would you say is changing from text to JSON as the response type? Pretty small, I agree, yeah, 1%. Like, you got to listen on the port, start the server, run the loop, wait for requests, check the request is valid. That's all going to change, not going to change if it's JSON versus text, agreed? You have to unpack the response, make sure you can get the body out, pass it to the relevant expression matcher, blah, 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 blah. And then right at the end, you decide, should I be returning JSON or text? So most of the stuff is the same. So would it make sense to reduplicate all of that logic in the handling functions? No. So this is where the pattern's useful. So if we go back a slide, what I want you to imagine is create greeter, which would be, for example, app.json. 99% of the code for handling servers would be defined in a function that gets wrapped, and then right at the end, in the JSON version, you would just say bundle it up as an object, and right at the end, in the text version, you would bundle it up as plain text. Do we see? So we have one actual function with all the logic that we maintain once, and we wrap those functions in the appropriate data type wranglers. And that is a good demonstration of where this pattern is genuinely useful. Looks like CORS does something similar, but I have less insight into what that is actually doing. But typically you see these patterns where there's high percentages of reusable code, A. B, where that reusable code is complex. So if you think back to this example, this is not a very good use case for this pattern. Why? I would say the complexity of function generating outweighs the value of just having a function that can take 2 parameters. That's pretty obvious. But do I want to maintain 2 different, HTTP responsing, is quite complex. I don't want to have 2 separate code bases for that. So that's where this pattern's used. There's another, okay, here's a description. So express.json creates and returns a middleware function configured with the default settings, and CORS creates one configured on your domain. This is another example that I have actually used myself where this pattern is useful, and it's around logging. So I don't know how much exposure you've had to serious logging systems. Logging is very, very important in critical systems. It's probably something we don't do a great job of actually exposing you to. You have to pick your battles in a 9-week engineering course. Logging is not only important to making sure our systems work, you've got to think about legal compliance, right? Knowing who's accessing your server, security, it all goes back to logging. I've dealt with serious cybersecurity incidences that were solved, or not solved, at least traced, because of logging. Okay, so logging is quite important. Where does this pattern fit? Well, who's done like console.log? Who's done console.error? We've not seen that? So there's typically different levels of logging. So console.log is a debugging level log. So it's like where you debug code and things. You should not have console.log in production systems. Console.error you can use it right now. It's built into JavaScript. It's an error level log. So it's something that you log when you know you're in an error case, for example. But there's console.warn, which might be, it's a in-between error and logging. And various different systems have their own taxonomies of different various levels of logging, okay? There's no set answer. There's default ones built into JavaScript. So imagine if I'm building a big production system, it's used by 1 million people, and I have an error level log. Is that more important than a console.log? It should be very, very important, right? So maybe when I have a console.error, 90% of the logging code is exactly the same. I need to get the message of the log, pass it out to the standard output, put it somewhere in a file, etc. But maybe for console.errors, I need to send an email. You see? So I will typically create a logging factory that has all the default logging code that should occur for every log regardless of the error. And I can wrap that in specific levels of logging functions that will do the slight differences I want to be done. In some cases, all it is color coding the log. So you do red for errors, blue for yellow for warnings, green for log, something like that. Does the pattern make a bit of sense? And so this is just a code example here. I have a with logging function, which means, this example might be slightly different actually. So with logging is like, this is actually a really cool example. So that was everything I said was still true. This is a slightly different example. With logging is something that we do when I want to call a function, any function in my program, with logging. So what are my options if I want to have potential logging on any function? So A, I could put if statements in all the functions. That's annoying. That's lines of code, right? Like if logging is passed in as the variable true, then log this, else don't. I could do that. There's probably some other options. Or I can wrap the function I'm calling in the with logging parent function, which will, so I pass the function I actually want to call in. It just wraps it surrounded by some logging code. That's what this example is doing. So with logging, accepts a function, any function, I don't know the type. This is cool. So it's a very generic wrapper. I return another function, and I don't know what it accepts. It could accept an array of arguments. I don't know. And what we do in that inner function when it's called is call console.log and then call the function. And then when I want to use it, so say I've got this add function here, just a normal function, I can just say I want a logged version of that function. So I call the function generator, it spits back out a function that calls that function when it's called. And so this will log the parameters passed in. Do we see the pattern there? Make sense? That's about the level of detail we'll go into. They're useful sometimes. I don't know if you need to use them. It's probably one of those things that you never technically need to use, but it can make your life a bit nicer and really reduce the amount of code. But I would warn you here, make sure the complexity is warranted by what you're trying to achieve. There's not too many use cases where you probably want to do this. Cool?
Do you need the three dots?
Yeah, here you would, because you don't know the number of arguments. So this is unpacking arguments into an array. I think in Python they're called decorators. You sometimes hear them called decorators. So it's a function that adds another function to add specific behavior. Logging, timing is another one, so profiling. So what you do with profiling is that you have a series of functions in a program. You want to know which of those functions is slowing down your program. I've actually done this myself with my ZSH initialization script. It was getting slow. So what would you do? Do I want to go through and add timing code to every single one of the functions? Maybe they're functions that I don't even control. Maybe they're functions that are compiled and I can't even edit them, right? So I can create a timing parent function that just prints a date time stamp of when that function was called. And then I call all the functions I'm trying to call wrapped in that timing function, and I get the timing out. It's a very cool pattern. Authentication is another massive one, actually. This is probably what we should lead with. So you've got some functions to call, but only certain types of people can use them. Do I want to add if statements that check authentication to every single function, or do I do it once in an authentication parent function, and then if the authentication passes, you call the inner function that was passed in? Oh, that's quite nice. Cool? That's it. In the uploaded code, I've got some examples that you can run, but I'm not going to spend the time doing it today. All right, ready to move on to new topics? New topic. This one's not too bad. Data persistence. All right. Maybe for some of you, this is the first time actually we are properly persisting data, because we don't do it in 1511, right? And this might be the first time. So this is very exciting. Yeah, all programs use data. We know this. Most of the time so far, for all of you at least, data is probably associated in your mind with variables. Is that true? In the context of you writing code? Kind of? What else is it associated with?
Zeros and ones. Does anything.
Anything?
Yeah.
What does that mean?
Basically anything.
If I say what's data, how do you store data?
SSD.
But I mean when you're writing code. Do you know how to write code that accesses the SSD?
I took 152 on that.
Well, then I'm not talking to you. Okay, well, you took a different course. Okay, well, so far, at least in 1511, 1531, if you think about this course, all data has been stored in memory. This isn't a bad thing, it's just what we've been doing so far. So we have, basically in JavaScript, everything's an object. In 1511, everything's a variable, which is a piece of memory. Arrays is another type. But these are all in-memory storage. So this is in what hardware component of the machine? RAM. Be it your local laptop or a mega server. In-memory storage is in memory. When we say memory, typically, we're talking about volatile memory like RAM. That's right. So that means if electricity is cut to that hardware, what happens to the memory? It's gone. It's gone. Now, does this make sense? If you're Instagram.com, right? Does it make sense? Not really. Does it make sense that I could, if all memory was stored in RAM and I shut my computer off, I'd be starting from a fresh slate, which might be nice. Fresh slate every time I reboot it. Doesn't make a lot of sense. Why isn't everything RAM? RAM is also very, very expensive compared to other storage types. So we can't put everything in RAM financially, actually. Just doesn't make sense. But also very useless if we lose it every time we power off the device. Imagine you'd never even be able to reboot the device. So you couldn't even do like a server update. It's just stuffed. So it doesn't really make a lot of sense. So we need to persist data sometimes. Persistence is just actual storage. So storing it on something, on media, that's often much larger in volume, much, much cheaper. What's the downside? Much slower. Much. Our programs would run far too slow if we use this as our only memory location. We know this from C, right? From 1511. Okay, there's lots and lots of different ways to persist data. When we think about software engineering systems, like we're talking about in this course, actually it's one of the 3 core pillars of layers. I don't know if we've spoken much about these layers. You have your presentation layer, your business logic layer, and your data layer. So if you think about the process of hitting an endpoint, trying to register a new user to a system, first you make the endpoint call. So some web client makes a request to an endpoint. That endpoint is the presentation layer. It's like being presented to the clients. So it's the outward-facing logic. That's your API. Yep. That, in turn, if everything's right, it's authenticated, it's packaged up correctly, we'll call your business layer, which is your actual functions. You've probably started seeing this in your iterations, right? Your actual inner functions that actually do the thing, the business logic, it's sometimes called. I don't know why we call it business logic. I don't really like the name, but whatever. But it's actually where it's like the things actually, processing actually gets done. The presentation layer, you can think of it as just like gatekeeping, wrangling, maybe you change some formats, but then you pass it on to do for the actual work to be done in the business logic layer. But then, very importantly, we have to have our data layer. So we have to persist the data. So if I'm registering a new user, typically, for I would say 90% of the systems in the wild, this is a database. So if you go off and do, is that right, Liam? What's the database course code? 3311 maybe, okay. You learn all about how they actually work there. But that's typically where you do it. So you do your business logic, you do your processing, you create the user, you get the ID, and then you say, okay, this needs to be saved to a table. You do that, that table might give you back an ID, and you return that back to the user, for example. But databases are not the only persistence mechanism. You can have files, that's a persistence mechanism, right? It's saved to disk, and there's other types too. So here's a little table of what we can do. So obviously we can store things in memory. Really? Did the call end? That's annoying. Why is that happening? Hopefully that's back. So, all right, we can store things in memory. It's not persistent. It's very easy to do. It's very fast. We can use a file. It's persistent. It's really easy to do. It's pretty fast. Or we can use a database. There's various types of databases. Let's not worry about them for now. They're persistent. They're more complex, but they're getting actually less and less complex for users to use. And they're very, very fast. And what's missing from here is scalable. So you can have databases with massive amounts of data. The point of a database is that it very efficiently can store and retrieve data. JSON files or in files, you can store little bits of data very easily, but they're not very efficient. We'll talk about why that is. So for this course, in all the projects and things, we're just going to be looking at in-file persistence. But be warned, typically you would be translating this to a database in a real sort of system. Okay, but we're going to be able to do what we need to do with a file database. Yeah. So we're going to use JSON. JSON's great. It's structured, but it's human readable. It's very useful because, if you want to just go through it yourself, you can just read the whole file. It's very, very, very useful. Now, it's less useful when your files are massive. They're also very slow as the files get larger. So like I said, there's downsides. But it's kind of, think of it as like a structured, very simple database that we can use to persist data. And the other thing is we can learn how the other layers interact with the database layer very simply. So it's pretty useful. So we're going to take a pretty simple approach. So when the whole server boots up, right, because the whole point of this exercise is to persist data. So when the server boots up, we look for a JSON file on disk and we turn it into memory. That's typically even how databases work. And when we want to save new data, or data at all, to the JSON file, we take some data structure, we stringify it into strings. Because remember, all files are strings. It's all text, right? Well, not all files actually, but there's actually binary files and text files. But for now, we're just going to do text files. Stringify it, so we pass it to, what is this? There's a stringify function. I forget exactly what it is. JSON.string, yeah. Yeah, JSON.stringify, that's right. We stringify the data structure and we write it back to the file. Now, what you'll note here, if you're sort of thinking about it, is, well, what does that mean? It means that every time we make a change, we write the whole JSON object back to the file. That's where we're losing that efficiency. So if you think about a database, the great thing about it is if one of you wants to update your name or your nickname or something like that, you just edit that piece of data. Whereas in this approach, you want to edit just your first name, the whole file gets rewritten. And that's where it's inefficient. But for small pieces of data, it's completely fine. Computers are so fast, right? Who cares for most things? Cool. You could do something like only write bits of a text file, but it's so complex that you're better off just using a database. All right, let's look at some code. This is what makes this all possible. Who wants to take a guess at what FS stands for? File system. So it's a Node library that lets us, remember, what is Node?
A runtime.
Yeah, and it's a runtime that, the student said the word runtime. It's a runtime that is designed to allow us to do system level interoperability. Because JavaScript was not designed to run on systems. Where was it designed to run on? Not quite. The browser, yeah. The browser. And browsers don't have file systems. So there was no file system code. So Node was like, well, we've got this language, it's kind of useful, it's all over the web, but it's not on backend, so let's make something that adds all this extra functionality. And so that's what Node actually does. And the FS library, which is part of Node, lets us do file system calls, so create files and things. Okay. So let's look at some data around emails and usernames and things. So our interface, our data type, is an array of users. And each user is just a name and an email. Really, really simple. We all know what an interface is, right? So this is like defining the data type. All right. Here we have a variable called data file. And data file is just going to be the name of the file that we'll store in the file system. So that's actually just a string here. All right. We have the load function. When will we call this load function? When the server boots. So you would have app dot, what is it? Listen. And you might have a function that you call there and you say, okay, first of all, load the data, get the data, then you're ready to start listening. And let's look at this code a bit closer. So load is a function that we're defining that returns back the interface type data, which is that interface that we described on an earlier line. When that function's called, we execute this line. So the first thing we need to do with files is we can't load a file if it doesn't exist. This will throw an error. So we need to check that the file is actually there. Pretty standard thing that we need to do. And there's a function for that, fs.exists_sync. Whenever we see sync in node function calls, what does that tell us? Maybe we haven't discussed it much. You've used sync kind of in the curl library. Is that a hand? Yeah, but you can't say sync means it's synchronous. So I know you know what it stands for. But what does it tell us? What does it mean? So, and I'm just repeating for the microphone. So it means that we will call this function, but we will wait for the operation to complete before we continue. This is different from default actions in JavaScript, in which you would typically pass a callback that gets executed when the file is loaded, but your program can continue running. But because we don't want the server to start until we load the file, it makes sense here to do it synchronously. So this could take a couple of seconds, in a worst case. It won't really, but whenever you see sync, you have to imagine in your mind, this is going to pause here. Got it? All right, so we say fs.exists. That makes sense. We're checking, does that data file exist? If the file exists, we want to load it. How do we load it? So JSON.parse, because we're going to get back a string that we hope is in the JSON format, but that's a problem for later. And we will pass the result of calling the fs function read file, and it's also in sync mode. Now, a read file takes two parameters. Number one is the location on disk in which we're trying to read, which is just the data file. Now, at this point, we know the data file exists because we can only be here if fs.exists was completed. And the text format of the file, which you should know because you will create the file. And we will use UTF-8. Cool? If the file didn't exist, what does that tell us? Not that there's no users. Sorry, let's go. What were you going to say? We haven't ever run the server. Yeah. Or someone deleted the file, I suppose. But most likely it's that this is a fresh boot. That's right. But regardless, the file's not there, so we have no users, so we can just create an empty array. And when we save, then we'll create the file. If we never save, we'll never create the file. Okay, cool, makes sense. And then, of course, so that's the load. Do we have any questions on the load logic? No? Okay, then let's look at save. Save is even simpler. You accept the data, which is in the type data. Data, remember, is an array of users. And it's very simple. We fs write file. This is the writing function on the fs library, also in synchronous mode. The first parameter is the location on disk in which we will write to. That makes sense, yeah? So that's also that data file. And we will write the result of calling JSON.stringify on the data variable that's passed in, I will actually need to look at what the last two parameters mean. Does anyone happen to know? Anyway, let's have a look. But that's all the logic for, where's VS Code? Is this being shared? Should be. Yep. Oh no, I didn't add it. I gave them all to Rani. Really? Are you sure? Because I didn't have VS Code shared.
No, it's just stuck on the slides. Can you try and change this? Like, on the slides, can you try and get rid of the slide? Yeah,
Is that, what's that doing now?
no, it's just not shared at all.
It's working? Okay. We have to figure out this thing later. Okay, persistence. So you'll need to no, you shouldn't need to npm install, do you? Let's look at that later. This is the same code. All right. Let's see if this runs. So tsx, is that what we're using? Is that right? Yeah, tsx persistence.ts. Cool. So if you notice, we have this data.json file that just got generated. So by default, if I have this data file as a string here, it's relative to the directory in which this code was running. You might need to change the path. Absolutely, but not a good idea to do something like this or something like this because file systems are different. What if this is run on a Windows machine? That might mean something different, etc., etc. So in FS, there's a whole I know they can't see this online. It should do. No? Oh my god. Can you see the slides? Do you want to try video, that ninja thing? Okay, can you give me the URL? Yeah, let's go to a break. Yeah, let's go to a quick break. Sorry, guys. please. It could actually, it looks like it's Chrome that's causing issues. So every time I go to Chrome,
I wonder if it might be permissions.
can't be permission. I don't think it's permissions. Let me just quit Chrome. Let's see if it happens now. Okay, all right. Sorry guys, this is annoying. So the first time I ran this program, let's have a look. We do data.load. Sorry, we just say data equals load. So let's jump over to the load function. We saw this earlier. We see if the file exists. If the file doesn't exist, then we just return an empty object or an array, object of an array. But if it does exist, we read the file. Then what this program does is creates a new user with the name Alice and the name emails. It pushes it to the array. This is the local memory. And then it saves that to the file. So, and then we do some logging. Now, if I quit, well, this is not a server. So if I rerun this file, what's going to happen? Say that again?
The initial loading users are going to already include Alice, because if we look at our JSON file, behold, there's
So then what will happen?
you're probably going to end up with just 2 Alice.
Very good. We'll have 2 Alices. I think that's the case as well. Because we load the file, create the new Alice, add it to the array, and save the object to the file. So every time we run this program, we'll get a new Alice appended. And we can see that there's 2 Alices in the loaded users in the logging. It's pretty cool. So we're persisting data here. I can reboot my machine. And because this is a file on disk, it's on the SSD of my Mac, and it will be loaded, and it will continue running. And JSON's great because it's structured. You can parse it with JSON.parse. You can turn data into JSON. Sorry, you can turn JavaScript objects into strings with stringify to write them back to the file. So that translation is handled for you, and you can continue persisting.
I think the biggest disadvantage of JSON is it has no comments.
JSON does not have any comments, but there's JSON-C. Have you heard of JSON-C? So there is an extension to... Yeah, there's some JSON file versions that have the ability for comments. Or does YAML have comments? Yeah, so... Right, yeah. So there's options if you want comments, but typically for things like this, where it's like being treated as a database, you don't really need comments anyway, because you're not writing the JSON. The system is. But that's a good point. JSON does not support comments in this specification. If you think about it, JSON was just designed for turning JavaScript objects into well, that's it, just a way to store memory. So it doesn't make sense to have comments there. We're still streaming. You can see the slides. It's looking good. And also, I realize it looks much, much better if I optimize it for my laptops. Anyway, that's a me thing. All right, so that's the basics of persistence. Now, how do we convert this code to work in the context of an Express server? Can we see all the building blocks? Yeah? So when we start the server, we need to load the data. And inside a route handler, we need to update the data when we have new data. All right. This was the old one, yes. Okay, so let's just do it ourselves in persistence. So is that not correct? That's how we do it, isn't it? Import Express from Express. I can look at last week's code if we get an error. Does this work? Yeah, that's fine. Let's look at right. Here we go. let's just copy all of that actually. So we come back over here. All right, so where would we put this load logic now that we've converted this to an express package? Oh, and I'll also need to do where would it make sense to load the data? In the life cycle of an Express server. Sorry? App.listen, when the server starts. The server starts when app.listen is called. So what we might do is, yeah, we might just do this. Right? So we say, well, we're listening on this endpoint, we load the data, and we console log that we're loaded. Let's comment this out first and just see if that worked. Whoops. Okay, so we're listening on port 3000 and we loaded 3 users because we used that same load function which loaded from that same object, so that's really cool. So that makes sense. Now what we want is an endpoint that adds a user. We don't want to just keep adding Alice every time this file runs. So now if we're writing correct RESTful code, right, how should we structure the endpoint? So it should be a post, yep. What would the name of the endpoint be? Sorry? Not add users, that's not RESTful. Remember we went through there's no add. What tells us that this will be adding a user? Sorry? Users. Isn't it plural? But how do we know that the post tells us we're adding the resource with the noun users? Do you see that? If we have add user, that's not RESTful. Because then it's like, is it ADD? Is it new user? Is it create user? Right? So we stop playing that game, and under RESTful specifications, we just have the noun as a plural. All right, so users there, request and result. What do we do when we hit this endpoint? Well, for now, can we just do the add a user code? Right? Let's just copy this in. We'll just for now, we'll just keep adding we'll just keep adding Alice. Now there's another issue. So the data.load is happening in app.listen, which means data is not available to the scope of the other files, right? So we can just say, actually we could just do this up here. Does that really care about order? We could just do it here. And then we start the server and we assume that that will be loaded by then. And that means that load will be available, the data will be available here, we can push to it, then we save, then we do that, then we return back the endpoint. You know, and we return back the data of the resource that was created. All right, so let's run this and make sure it runs. Why is it ending? Why is it ending? Why is it ending? Is that port in use? Yeah, I think the port was in use by something else on my machine. I might have something running. So I've just moved it to a different port. All right, so now what we want to do is hit this user's endpoint in a post request. There's no data that I'm passing in, right? But that should just create a new Alice. Now, so what are my options for testing out this post request? Can I do it in the browser?
Yes.
No, we can't do post requests in the browser, remember? Only gets. So what are my options? Curl or? Yeah, one of those like apps. What do we want to do? Should we curl it? What's the syntax? I'm actually going to have to remember. Well, I can just look at here. So we need to hit port 3002 to the endpoints. Let's actually send name Jake. Let's just send it. We're not taking it and doing anything with it, but let's send it because then we can make it work later. But if I hit that, oh yeah, this happened last time, right? It didn't like that. Look at that. That is so cool. So the response back had the data that was added, which was Alice, remember? Because we always added Alice. And if I look here, there should be this code that ran, which is here, save data.json. Well, it's printing out all the users, and then it's saying that we saved it. So if we go to data.json, whoops, there should be an extra one now. But this isn't quite right. We want to persist the data that the request created. Okay. So what might we do to do this?
Change the new users to give what the request is.
So how do we get the data out of the request? Here we go. JSON.parse request.body. Is that right? But it looks like I've got some type error here. Should we just see if this works? Like that? Let's test it. There's a type issue going on with this file. It's not loading the types for some reason. I probably need a package.json that I don't have or something. So let's just trust ourselves. So we take out of the body the email. Sorry, we take the whole body and we put it in body data. Then we get the .name and the .email, which map over to name and email, which matches the interface declaration for the user. And then that's the new user that we persist. So we shouldn't be persisting Alison anymore. So do we need to restart the server? Yeah, because we changed the server code. We load up those users. We go over here, we rerun the command. We do get an error, which makes a lot of sense because what didn't I do in the request? I didn't post the email. That's exactly right. And this will actually tell us probably, no, it doesn't even like, it looks like this line might be wrong. But so let's go and fix this first. So we can do that. Then we can say email. Okay, so I think there is something wrong with line 53. Okay, hold on. Does this work? No, JSON.parse is not working. So are we sure there is a request.body to string? Let's try that. Unterminated string. Oh, is there something wrong with the request itself? No. I don't think so.
Do you have quotation marks around both sides of the unit? Because I'm pretty sure you maybe...
Oh, yeah. Thank you. Okay, so it is getting that now. Name dot, so where's this coming from? Oh, hold on. Let's make this a bit larger. All right. That's getting printed, I think, here. It's not valid JSON. What's wrong with it? Is it meant to be a comma or a semicolon in between the keys? There's a comma, right? What did I do in the other? Object is not JSON. Does that mean we don't need to string? Nope. All right, let's find where this actually is. So oops. Rect.body is an object. All right, let's try and go to Safari so we don't crash the stream. Oh, wait on. Did I tell it to use JSON? Yeah, I did. That's fine. What are you suggesting? Yeah, well, that's why I didn't. Oh, because we're using express.json. Is this what you're saying? Yeah, it looks like you're right. Yeah, I mean, that did work. So what happened there? So because I passed as the curl type application.json, that came over to the Express server, and the Express server passed it for us, and then we were trying to pass it again.
Well, if you stringify it and then
Yeah, but we didn't stringify it, and then.
oh,
But that would work, but that doesn't make sense to do that.
to string.
So basically, the request.body was already in the JSON format. Because we're using this express.json mode, and the request had that it was in a JSON mode request.
Turn it back into a string and then undo it again.
Well, we have to, so let's run through it line by line. So let me just remove that. Remove this. Let's just talk through it. So, whoops. And let's make this a bit smaller. So because the Express server is run in JSON mode, the body has already been passed to JSON somewhere in that Express logic. So the error we were getting was trying to pass it to JSON twice. Right? Because passing JSON expects it to be a string, and it wasn't a string. So there was an error.
But didn't we turn it back into this
But-
string with the two string? So then when we pass it,
But there was no
but if we turned it back into a string and then undid it again, shouldn't it?
Did we use stringify instead of just string maybe?
Yeah, that's right. We didn't stringify it with JSON.stringify.
Oh, we
Yeah.
But what's the difference in two string?
ToString is probably put on the object if it's not in JSON mode, but it's already in JSON. So you are meant to pass back to stringify.
Oh, okay.
It's a bit harder without the types here, because then we could have seen that there was no ToString call or wasn't doing what we expected or something like that.
So if we did stringify, it would have worked.
Probably would have worked, yes. Yep. Because the data was there because we could print it. That's right. So request.body is in, see, we have no types, so it doesn't matter. Request.body is the JSON, which means there were two keys on it because we passed in name and email as the two keys. So we take those values and assign it to a new object with the keys name and email. All right? That matches the interface user, and we store that in an object called new user. This is a pretty common method of taking the data that we want out of a request. And then we push that to the users array, which we've seen work because there's the data there. It's pretty cool. We save that data, that's where it gets written to the file. Then we're just doing some logging. And this is really common, we send back that new data to prove that it kind of worked. And typically what you would do there is like add an ID or something new from the database that proved that it was persisted and that could be used to access the resource in the future. But that's the other thing, we don't have an ability to do something like that with JSON the way we're doing it. Unless we could retrieve the index or do something like that. But for something really simple, this is great. You can come in. No. Yeah. All right. The other cool thing we can do is like kill the server, and we can edit the data. So we say, these are test users. All right, we don't want those. So now we just want our real database. So we restart the application, and we only have that one user. So that's the value of JSON. Very, very easy to interface with, but it's not very secure, right? So if something happens to this file, it's all gone. The server's still running, Liam? 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 Is the server still? Yes. It's right. The slides are still good. Okay, all good. All right. Cool. And we've had to play with this. So we've restarted the server and it's still there. There's two strategies for persisting data or deciding when to persist data. The first is what we're doing. So anytime we're saving new data, imagine this JSON was very, very large. It could actually take some time to save the data. So if we're doing it every single time an endpoint is hit, and you have to imagine you might be getting 50 requests all in the same second to add a new user. And if every time we process a request we have to save the data, that could be contentious. Do you see what I'm saying? There's a limited resource. So anytime you're interfacing with hardware, you're limited. There's only one SSD, right? Even SSDs are very fast, but you can't do 50 writes at once. So you see how you're contending over a limited physical resource. So there could be bottlenecks here. In fact, there are. This is not a good way to do something at scale. It's a nice little way to do something simply. So if there's lots of frequent writes or writes at the same time, this could be inefficient. But you could do something else. So you could say, anytime I get the request, add to the JSON, to the data object, like data.push, the new user, and then in an internal clock, every so often, save that to the file. What's the risk there? Yeah, if your server crashes before you save, any data that occurred after the last save is completely lost. That's a terrible strategy. You're better off making some of the requests a bit slow. But honestly, again, you would never do this in a real system, but imagine you're getting 1 million requests in a second. The first attempt might not actually work. Might be just too slow. I did recently just merge the stuff from last week, but this is up there, I think. I don't know, wherever Rani put it. It should be 5.2.
It's still showing the old one.
Oh, really? I'll have to talk to Rani. Sorry. Tell that student. I'm sorry, student. Yep, sorry. I'll send you the PDF of this afterwards. Okay, any questions with this? Is it all making sense? God, nothing is working today. All right. Persistence keeps our data alive beyond the runtime of the server, beyond the runtime of the hardware too. Think about, there's lots of reasons servers go down, okay? Think about, so you've got a server and you need to update the code that's running. So you're updating the application. You've got to typically take the server down. So any unpersisted data is lost. So basically you need to think as a software engineer, any data in memory could be lost at any millisecond. And that needs to be okay. With the approach that you can take in the assignments, you can load a file, like that's completely fine. We're doing pretty limited things, 2-3 users at a time. It's first step, we learn a lot of things, but it's not as reliable as a database. Cool? All right. I do have another little slide. Okay, you should be able to see this. Yeah, cool. Did you want to break, or you're okay? We're okay? All right, cool. Exceptions. Who knows what an exception is? Yeah, it's an error. But there's lots of errors, and we've never really called them exceptions. So exceptions are ways we can respond to when errors occur, and perhaps we can respond more gracefully than we otherwise would have. We just had an error in our program before, didn't we? And what happened to the server? Sorry? No, it's worse than that. Didn't just not do anything. I can show you, right? So if we go back, so like the query was malformed, right? What's happened to the server? Actually, it didn't crash, did it? So how did this error occur and the server not crash? The answer is by handling the exceptions. So if Express was not handling this exception, truly the server would have crashed. That's terrible because it means you have to understand, right? This request was incorrect and it did cause an error. But your request might be completely fine. Why should the whole server go down because of one malformed request? That's not very good. Now, the developer should be aware of the error. The requester should be aware of the error. I might need to log the error, but I don't want to catastrophize my entire server. So how do we respond to errors that we may or may not expect gracefully is the language feature of exceptions. It's a very, very common pattern in very, very many programming languages. That's the wrong slide, isn't it? Oh, it's still sharing. Oh, that's great. Okay. So that's what exceptions are. We have language features to handle exceptions. And we'll talk about how it works within testing. Okay. So the simplest way to handle a problem if something goes wrong at runtime is to just crash. So this is typically our last resort. If you have error handling, it typically means you didn't handle that error. So it typically means you're in a position which you just did not expect. Let's have a look at this example here. What we're saying is, I have this function called getGrade, whatever. It might turn a numerical grade into the label, like credit, pass, distinction. Okay. if I get a score that's less than 0 or greater than 100, so you're like, well, that's not a valid grade, right? So at UNSW, grades are between 0 and 100. Maybe that's not the case elsewhere. If that happens, I just can't handle this, right? Like, I just don't know what to do. What would you do? How do you have a negative WHAM? It should not be possible. This value should not have occurred here. I'm just going to quit the program. And that is actually a perfectly valid way of handling a problem. Because what do you do next? I mean, you can't say that a score of 110 is a distinction or a high distinction, because it's not. It's just not in the acceptable range of parameters. Now, if this is a little local program that you're running for yourself, you could just crash and say something went wrong elsewhere to deal with it. Again, though, if this is a server and the server crashes, you're no longer accepting requests and you're losing money. That's bad, right? It's all about money. It's brutal. The whole program dies. There's no cleanup, there's no explanation, there's no logging, there's no tracing. You're losing money. Your investors are sad. You're going to lose your job. So we don't want that. So we need a better way. So exceptions are a language feature in JavaScript. And like I said, they're a language feature in many, many programming languages. And an exception is an event that's triggered when something happens that is exceptional. So it shouldn't happen typically in the flow of your program. Some people overuse exception handling. It's in the name. It should be exceptional. It's usually caused by an error, such as invalid input to your function or something like that. Or, for example, if something's not there that you expect, like a file. So, in the example of the grade, and we have some nice new syntax here. So if we have a number out of the range that we expected, what we can say is, rather than just quitting the process, careful, laptop down. This is valid JavaScript syntax. We throw a new, and what we're throwing is an exception, and the super type of the exception in this case is the error exception. There are different types of exceptions. Error is a classic and standard one because we're doing error handling, right? And the error accepts a string which describes what happened. In this case, we're just saying, well, the score should be between 0 and 100. I'm not handling this. Now, why is it called throw? What's happening with new? What's going on? When we throw an error, we quit, continue. Let me rephrase that. When we throw an error, we stop processing from that point onwards. Okay, the idea here is that I cannot and will not, I still do not want to run, where's my mouse? This line of code. It just doesn't make sense, right? I'm not happy. I'm not dealing with this. In this case, what's the question? The question is, well, then who should deal with it? You're being too clever. Think as a, so okay, what's your name again? Yushang. You are the getGrade function, and you accept what parameter? A score, okay? You are the caller, you provide a score, a number. So right now, call the function and give a number. Give a valid number.
87.
Okay, now return back.
80. Wait, return.
Pass.
Yeah.
Return it back, like look at her.
Pass.
Okay, good. All right, now do the same thing, but pass in an invalid number.
Minus 2,436.
Okay, now you need to throw an exception, and I'll let you decide with how you want to do that physically. No, just like, you just like have a mental breakdown, right, or something, right? So you're just really unhappy, you throw your laptop to the ground, you're like, I can't do this, right? Agreed?
Yeah.
So who should clean up? Is it you? No, because your job is very simple. Give me an appropriate number. It's your problem. Do we see what I'm saying here? So throwing an exception, you're kind of throwing back an exception and saying, no, that's ridiculous. I can't do that, I won't do that. And you need to clean up and handle this. And maybe you're able to. You're like, oh, sorry, I gave you the wrong thing. Like, let me fix this. So when you throw an exception, you're giving back a piece of information that potentially the caller knows how to handle. And the verb for handling it is called catching. It's like, I should get a ball or something. You can, I might get it. Don't put in like a HR thing, right? So like if I throw the error and you're like, okay, I can catch that error and I can fix up the problem, and then you can make the request again or do something. Don't throw it back. Not just yet. But actually the point is that the caller needs to decide what to do. We don't actually know. You might have been, it might not be your fault, right? Like you might have been given bad information from a HTTP request. It might not be your fault, and you got to just pass the message on. You got to, like, these are long chains. Okay, I'm going to talk. So how do we catch? Or okay, so the trick is when you make the request, you need to know that you're calling potentially throwable code. Is that making sense? So you need to know that I'm trying to do something that might fail. And that word, try, is critical, so critical that it is the verb in the syntax. So you're not calling getGrade. No, you're trying to. And only if you don't throw an exception will you complete the process. Okay. So anytime you want to call throwable code, you need to wrap the code that you actually want to call in a try block. So in the example here, this is a good little example. We have, I'm going to try. So all that syntax here does, have we seen this syntax before in JavaScript? Maybe online? No, it's okay if you haven't. Yeah, it's in many programming languages, try catch blocks. So you say try. Now, when you say try, I want you to imagine for a moment that it's invisible. So those 3 lines of code, the 2 lines, the const and the console.log, will just execute in order, just as if the try block was not there. But if on either of those 2 lines, because they're inside the try block, any exception is raised, that's when you're throwing the exception back. You can throw back to me. And if I catch an exception, I can tell the program what it should do. So that would be the caller, in this case, you. And in this case, what you're doing is, okay, well, relax. Don't quit the whole program. I'll describe the actions that should take place. And in this example, what is now taking place? Well, don't make assumptions. We don't know where the log is going. We're just making a console log. I'm sorry, that was a bit much. That's correct. We're just logging to someone. It could be the user, it could be the server, it could be the, who knows where. That, sorry, that -5, that was not valid. But the point is, you had an exit path. Do you see what I'm saying? Because without this, you would have to run that error, which could run that line, which could get you into much worse trouble. Eventually, you could try and do something like divide by 0, right? Or like do something with hardware that's not, you could access memory that you're not allowed to, and then your program will actually crash because the operating system will kill it.
For the catch, I was like, catch on mistakes there, right? Is it limited to specific types of errors or like specific types of exceptions?
That's a very good question. Have you looked ahead or are you just clever? So there are different types of exceptions. So that we threw an error exception. And this is catching any type of exception. So this is a default exception. This is probably not a great way to do this because there could be other types of exceptions that were thrown and you're assuming that it's coming from that exception. So hopefully I've got a slide on. I'll show you maybe when we get into some code some better examples. But you can actually define your own exception types. So you could define an exception type called like invalid score range exception error. And then you need to catch only the type of invalid score range exception error in this line. Where's my mouse gone? Here. And it's possible to catch multiple types of errors and do different things. So you could have like a default error, which is like, look, I don't even know what's happening now. Log the error and quit the program. Like you could still decide to quit. Quitting is always a viable option if you're in a lot of trouble. That's actually just good life advice, right? You can always just say no and not do something. Like most of the students do to coming to these lectures. So I guess you do know how to do that. Ha ha ha. Okay, all right. So this raises a paradigm of thinking. It's easier to ask for forgiveness than permission. So this is a modality of thinking about calling potentially errorable code. That was not very good. So just do stuff. Assume it'll work. So try it. And if it doesn't, we'll catch it. That's what we just tried with that example before. Like, what's your name again? Sophia might not know that you can't handle negative whams. She just might not know. So she just tries. And then you have a hissy fit because you don't like it, right? That's completely viable, and it falls under this paradigm. It means that you don't have all these pre-error detection logic riddled throughout your programs. So it just makes things a little bit more straightforward. But the control flow is harder to read because you need to be thinking, hold on, that might have failed, so I might be here. Okay, what should I do from there? Do I recover? Etc. So it might be harder to reason about what position you are in the program. There's a different paradigm of thinking, look before you leap. It's the opposite idea. And this is where we do all the checking first to make sure we're in a position where we should execute. So here's an example. We're checking our data types. That's a very common type of error prevention. We do some validation. Like, if you think about it, you know that error we just had, right, where we didn't know the data type of the object passed in? Imagine if we did something like this. It's like, hold on, before I try and turn this into a JavaScript object, is it a JavaScript string? Does it start with a curly brace? Because all JavaScript objects should start with a curly brace. Do you see? If that's all true, okay, now let's do it. Let's do JSON.parse. It's a bit more careful, it's a bit more structured. We hopefully don't cause exceptions, we don't cause errors. Our logs are a bit cleaner. But like I was saying, it does make it all a bit ugly. You have if statements here, if statements there. You don't know that you checked every error type. Your code is probably a bit more sure, but it's messier. And you could just miss things. So you probably need a try-catch anyway. But this stuff is an art. We don't want try-catches everywhere either. That's also really messy. I've seen people do really, really weird things where every single line of code in their program is in a try-catch block. And it's like, well, at that point, you should just not have it because, you know what I mean? So you want to be tasteful in where you do this, and it should be in places where you know you're calling code that could throw an error. And there are actually lots of tools and testing frameworks that will tell you when you're calling throwable code. It can just detect it actually automatically and warn you that you should do some try-catching here. So you should be thinking about in your programs, where do you have lines of code that may cause potential errors? And I'll tell you a hint. Often it's when you have user input, and often that's when you have a HTTP input, a request being processed. Look at the examples just before, like, is all the data there? Is the data in the correct key? Is the request in the correct type? So often when you're dealing with user input, things go wrong. And this is all towards thinking about making our code robust. That is what it means to go from being a programmer or a coder to a software engineer. Programmers and coders can do whatever they want, solve problems, right? And it's funny, I know colleagues and people in my life that I've worked with that are incredible, incredible, incredible programmers, like way better than you or I will ever be. But they're actually not great software engineers. They write kind of obscure, very good, but it only works in specific cases that can solve many problems very well, code. And I know other people that are very, 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 very good software engineers. And it's interesting spotting the two. I think some people are suited, or just the way you grow up, or the way you learn this stuff, where you're prioritizing what you're really good at. And the world is better with both of them. So the software engineers will call in those people to solve really tough problems, but the software engineers will make sure it's robust. That's what it means to be a software engineer. And there is no, oh my God. Well, we had a good run that time, so. How's that? There's no, if anyone, you'll meet in your life, if you go into software engineering, really sort of dogmatic people that are like, no, this is the best thing ever. They're always often wrong, right? So it's not like always do this or always do this. In reality, it's somewhere in the middle, and it depends on the case. There's no hard answers in life or in software engineering. So writing robust, clean code is such an art. This is a good example. So we're doing a bit of type checking, right? Is the type of the value that we're passed in correct? Is it a valid number in this case? We have a nice helper function. That's really good. This is nice and readable. And what we're saying is, and this is an example of guarding. I think I've spoken about this a little bit in 1511, if you remember, but it's like, before, like this is, like remember your get grade. Before I'm going to do anything, like let me just make sure we're all okay. Do I have my, ducks in a row or whatever the saying is? So is the score a number? Is it a valid number? Is it in the correct range? Let me check. If that's all good, okay, let me do my logic. And you get back a nice result on the caller. What's also nice about this is that there are two types of errors being thrown. There's a type of error being thrown if the score is not a number, and there's a type of error being thrown if the score is not in the range. Now, the problem here, though, is that they're both the exact same error type. So actually, you've got no way of knowing, the caller has no way of knowing which exception was thrown, but we can talk about the subtypes of exception handling in a moment. I guess in a way here it doesn't matter, because either way you know that the input number was invalid. But sometimes, so if it's going to change what the caller should do, then it should be a different type. But it means you have to catch each type. Does that make sense? There you go. Okay. Do we have any questions? Thank you, Sophia. Any questions so far? No? How does it all work with jest? So what if you want to test a case where your code should throw an error? Well, you have a to-throw expectation case. So this is very good. If you know that there's a branch of code that could happen, may happen, and is not viable, so it should throw an error, you should test that that is what happens. And so you can use to-throw. Where's my mouse gone again? And you can even test the string comes back as the exact case that was expected.
Like when we throw the error and we have the string that we is that all that we kind of receive?
You receive the string, so the value of the string, and you receive the type of the exception thrown. In that case, it was capital E error. But I'm just trying to make sure I'm not thinking of Python, but that should be a type, capital E error, exactly right. And you can do type checks on the exceptions. We should look at the JavaScript docs in a second to double check that. So if you pass get grade to -1, you say, in this case, I know I should get back some sort of error. Okay, and I expect to get an error. Great. It all gets handled and there's no crash. But of course, you can also test that in a valid case, you get the data you expected. So it's very, very, very useful. Note the arrow wrapper what is this trying to say? No, this, I mean, yeah, I mean, this is kind of obvious, but we need to call the function to get the error to be thrown, because the error gets thrown in the logic of the function.
So if we didn't have that like arrow section, it wouldn't throw it. Because I feel like we wrote out, at least I wrote my test without that arrow.
Um,
Test below doesn't have it.
Because it's still a function.
yeah, so what is this trying to say actually?
Get grade is still a function.
No, okay. Okay, this is interesting. Are you saying you wrote, are you saying you didn't do it for this? Like, because you haven't done it with exceptions yet, right?
Oh, okay, yes.
Okay, right, yeah. Let me explain. Who catches exceptions? Don't you say me? Oh, you're putting your hand up.
No, I catch exceptions.
Who catches exceptions? The caller. Who called getGrade here? Your test program. But there's no catch here. Do you see what I'm saying? So who calls here? Who calls getGrade? Oh, very good. The test does, not you. Because which function calls getGrade? Expect. And who wrote expect? Jest, not us. So can you catch the exception in this file? No, because you're not actually calling getGrade. Who is calling getGrade? So what is getGrade being used as here? A callback. Is that what you're going to say, I hope? Did I just finish? Sorry, damn it. It's a callback.
Wait, which one is it?
GetGrade is being passed into expect, which is calling it.
I think you're supposed to select the one of both.
Sorry, yeah, I'm talking about this at the moment. Yeah, sorry. Let me. Sorry. Does that make sense? So basically, let me explain one more time because it's actually a very good question. The to-throw jest checker internally must have a catch somewhere, a try catch. So think about it. To-throw gets called. Well, you gave me the marker, so can they see the whiteboard, Liam? So to-throw. Do you want to go to that one? Yeah, sure. To-throw gets called. Which means it's when in to-throw, there'll be some code that says catch, there'll be a try, the actual func, and then catch it. And if it catches, then you return like a pass of the test. You can imagine that. So the point is that the catch code and the try code is within to-throw. So you need to give it a function that it can call, which is what we're doing. Do you see? We're creating an inline function that's anonymous, and when it's executed, it calls getGrade, so we can surround it in the catch. We don't need to do that in this case. In this case, we can just call it and get the result.
So does the message have to be exact?
Yeah, that would have to be exact. Yes. Because this test is not just testing that an exception was thrown, but that the string matches.
Would that be black box testing?
That's a great question. Is it black box testing?
Can we just see if it throws any kind of error without knowing the message?
I think if there was no parameters, it wouldn't check the string. That's my guess, though. You should check the specification. Yeah. Or there might be different types of to-throw where it tests or doesn't test the value. My guess is that's an overloaded function to throw. We can look at this, right? Yeah. So if you call to throw without any parameter, it doesn't check the value of the string, just that there was something thrown. I mean, with the caveat, this came from an AI slop response. We can do. We can. We got 15 minutes. What else do I have? Okay, it is worth understanding errors in general. There's different types of errors. They all suck, right? But there's different types. What's an example of a compile time error?
Takes too long.
No. There's a syntax error. The program doesn't compile at all. Okay. It's frozen. Liam's got a protest or something. Oh. How's that? No? You do? Okay. Probably not. Well, we got 5 minutes, 7 minutes. It means there's something wrong with the code at the syntax level. Typically, that means it's not going to execute. We can have runtime errors. That's what we're writing. The try catches only test for runtime errors. It's like something in the runtime of the program, like a value, is invalid, incorrect, causes a problem. These are much worse, much harder to check for, and they cause us way more problems, because these are the problems that run at 3:30 a.m. that make your pager buzz because you're an engineer and the system's gone down. Why? It will be because of a runtime error. There's logic errors. So the program runs just fine. There's no error thrown because you didn't maybe even check for it. And this would be an example of if you didn't test for -1 being below 0, so you're saying -1 is a fail when -1 might be an invalid score. There's no error thrown. Everyone's happy. Maybe they did fail, but that something should have been an error there, but it wasn't encoded into the program. These are the worst types of errors, because not only did the program not do what you wanted it to do, you didn't even get woken up at 3:30 a.m. And maybe you just, if you're a bank, maybe you gave someone the wrong amount of money, right? Like, that's worse. You'd rather get woken up at 3:30 a.m. You'd rather know about an error, right? Well, sometimes ignorance is bliss. What can you do? There's also build errors. I don't know, these aren't really encaptured here. They don't cause us too much problems because typically we don't put the code into production if it didn't build, right? But they're still annoying. So exceptions let our programs fail gracefully instead of crashing. We throw an error with some information that could be part of the type or be part of the message, and we try throwable code and try to catch it gracefully and recover. I'll give you another example of code that I've written that does this pattern. So I've got a web system. There's a back end and a front end. Now, users on a front end might be, if I'm walking in between my office and the lecture theatre, for a brief moment in time, I might lose internet connectivity, right? Or if I'm in the elevator, right? You lose internet. But in that moment, I tried to make a network request from the front end to the server. So the code on the front end, I click a button and it tries to make a network request. And the network request fails. Why did it fail? Because I've got no internet. Make sense? But if I just wait 30 more seconds, I'll have internet again. So I try to make the request. The request fails, so I get back an exception gets thrown. I catch it. If it's a no internet connectivity type of error, I have I've written this code myself, a 30-second timeout, and you just try again. And it might just work the second time. And how fantastic is that? Because you've just saved your user from even knowing about an error. And the really cool thing is that actually ties into a lot of these things. The code that did the network error retrying was a function generator. So any time HTTP calls are called, that gets wrapped in a retry function generator that calls that actual requesting with that retry loop. So anytime you write any code that triggers an endpoint, you don't even have to think about it. It will go through that retry logic. So that's the function generator pattern that we saw earlier. And it's really nice, because most of the time that people don't have internet, it's because they're trying to use an app because they think they've got internet, right? People aren't on your web app in the car with no internet, because, I mean, they're not, well, users are really stupid, by the way, but they're not that stupid, hopefully. So Most of the time it's because they've just lost internet very, very briefly. So that's something that pulls in a lot of this stuff together.
Do you know error 40?
40? Aren't they all 3 digits?
What?
Error 40?
Yes.
Aren't they all 3 digits? What's the question?
It's a Danish word to say the user is stupid.
Oh, what's it called?
Error 40. The error is 40 cm before the screen.
Oh, yeah, there's also, what's the other one? There's an error between keyboard and chair?
Yeah, that's the.
Is that what you're saying?
Brazilian one.
Yeah, okay, all right, yeah. So if the error is between the user and the monitor and the chair, then it's, what you're trying to say is that the user's done something super stupid. But you know, good software doesn't care about that. Good software assumes all users are really stupid and are resilient anyway. But yeah, sometimes people do silly things. Anyway, that's a lecture. People are trying to get in, so we can end it there. You should play around with the exception handling stuff because it's often glossed over because it's not really super exciting to spend 3 weeks talking about exception handling. But the nuances are important. You should play with different types and you should play with different messages and you should do your own tests for catching doing tooth-row, like tooth-row test cases and et cetera, et cetera. Sorry about the connectivity issues. We got the best man on the case. We're going to try and solve something. I don't know what the issue is there. Speaking of resilience, but all right. Thanks, everyone.